Hello and welcome to this Science mini-masterclass. In this video, I'll be showing you how you can use physics formulas to approach non-calculation questions. This is something I found a lot of students aren't aware of, and it can massively help with structuring your responses and picking up the most marks possible. As always, the main focus is to secure the knowledge and help you apply this effectively to exam questions. Let's get cracking. So if you were sat there wondering what's going on about physics formulas, it's these, okay? This is an example of the physics formula sheet or equation sheets from an Edexcel physics exam paper. And we've got one here from AQA GCSE Physics exam papers. And these are still going to be provided in their fullest for the 2026 exams and the summer 2027 exams, to be confirmed what will happen after that. So in this scenario then, I'm looking at pressure, and I've been told that figure 3 shows two drawings of the same person on a bed. Now this question is an explain question. That's the command term. We've put a spotlight on it using the bug technique. B for box the command term. Now explain, you need to be thinking what is happening and why. Okay, I need to consider what is happening and why in this scenario. And I'm going to use the connective because with an explain question, part of the marks available are for you justifying what you have said in the first part of your answer. So there needs to be some justification when I write my answer, and because is a great connective to use. And I've been asked to explain why the person exerts a different pressure on the bed when standing than lying down, and it's worth 2 marks. Now, as this question is asking about pressure, I would look at my physics formula sheets and I'd look for an equation, could be more than one of them, with pressure in it. And I'm going to select this equation from the formula sheet because it relates pressure to the force, in this case force of weight from the person acting over an area, and the area is obviously the area over which the force of weight is applied or exerted to the bed beneath. Now, I'm going to go straight in and write that equation in. Sometimes we'll get a mark just for selecting an appropriate equation to go with the scenario. Not always, but sometimes. Nevertheless, shove it in and build the answer around the equation. So if I've got to talk about why the pressure is going to be different, what factors or quantities are going to be the same and what are going to change? So in this scenario then, comparing the person lying down to standing up, the force of weight will remain the same, but the area of contact with the surface is going to be smaller, which is why the pressure exerted by the person standing on the bed is going to be greater than when they are lying down. Okay, if you're struggling to understand why that's the case, if we shoved some numbers in, let's say the person had a force of 500 newtons and the area when they were lying down was 2 meters squared. 500 divided by 2 would be 250. And then if when standing up the area was 1 meter squared, 500 divided by 1 is 500. So the pressure is greater when they're standing up because the force of weight remains the same, but the area of contact with the surface is smaller. We've referred to these quantities as part of the equation when explaining why the pressure is different. And I get 1 mark for saying the force is the same and 1 mark for saying the area of contact is smaller. Let's have a look at another one. This is a more challenging question. This was from an AQA exam. And in this one, I've got to explain why the acceleration of an aeroplane accelerating from a low speed to a high speed with engines at maximum power is not constant. It's worth 5 marks. Now, before I pick an equation, let's have a think about what's actually going on here. We've got an aeroplane. there's going to be the forward force from the engines, okay, essentially thrust, and then resisting or acting against the force from the engines in the same plane is air resistance, okay? And just for the purpose of this diagram, I've obviously shown the force from the engines as being slightly bigger than air resistance. So to help me choose the appropriate equation to build my answer around, I need to be thinking about what equation has got acceleration in and force. This one here, resultant force equals mass multiplied by acceleration. Now I'm going to begin by writing out that equation, which is for Newton's second law, with acceleration as the focus of the equation. A equals F divided by M, A equals force divided by mass. Now, I haven't picked up a mark from that, but it's going to help me structure the rest of my answer. So, again, I need to be considering what is going to change and what's perhaps going to stay the same from those quantities. So, the resultant force then, F, it's based on the force from the engines minus air resistance. I'm going to get a mark for that. At maximum power, the force from the engines is going to be constant. So this arrow is as big as it's going to get for the force from the engines. Mark for that. As the aeroplane accelerates, air resistance increases. Okay, when an object accelerates, air resistance will increase as the object gets faster and faster as part of its acceleration. Okay, so this arrow would continually get bigger and bigger and bigger until it eventually matches the force from the engines. That would be terminal velocity being achieved there. But nevertheless, let's continue. So we've got air resistance increases. Well, what effect is that going to have on the resultant force? Well, if the resultant force is based on force from the engines minus air resistance, then the resultant force will decrease. Okay, if this value is remaining constant, but this one's getting bigger, then the resultant force is going to get smaller. 4 marks so far. Now, I've got to relate back, it is an explain question, to acceleration and how a change, in this case a decrease in the resultant force, would affect the acceleration. Well, if this value is getting smaller, then this value for acceleration is also going to get smaller because acceleration is directly proportional to the force, or in this case, the resultant force. There's my 5th and final mark. Once again, I've used an equation to build my answer around the different quantities. If you sat there thinking, why did you not mention mass? There is going to be a minimal change to the mass as fuel is combusted by our aeroplane, but for argument's sake, mass is going to remain relatively constant here. Didn't need to refer to it. There wasn't a mark available for it in this particular question. Final one then for you to have a look at. This is to do with momentum, okay? And this is actually higher tier content for various exam boards, Edexcel, AQA, and so on. What I'd like you to do is have a read of this question and apply your own knowledge of momentum and conservation of momentum in collisions, and have a read of our students' answer in purple and decide how many marks that answer would be worth. Pause the video and we'll review in a moment. Okie doke. Hopefully, you've come to the decision that is worth a beautiful 3 marks, a lovely answer there. They actually got a mark for this one. I mentioned it earlier on. Sometimes you will get a mark just for applying a suitable equation to the scenario. So they get 1 mark for that. They get a mark for mentioning that in a collision, momentum is conserved. In other words, the combined momentum of the 2 objects in this system, P and Q, would be the same before the collision as it is after the collision. Now, we are told they stick together, which means the mass is going to increase. And if the mass increases, the value for mass would go up. And for momentum to stay the same after the collision, then you're going to have a decrease in the value of velocity, which is what the student has said in the final sentence. Okay, and they pick up specifically the third mark for mentioning an increase in mass there. And that's part one of this Physics Mini Masterclass series complete. Join me for part two, where I'll be showing you how to use the physics formula sheets to approach method writing questions related to some of the required practicals. As always, if you found that useful, please hit the like button. And for more mini masterclasses, please subscribe to my channel, Science Mini Masterclasses. See you in the next one.